Hi everyone, Mr. Ford here. Today we're going to go over your kinematics test. These are the select questions from the multiple choice where um, overall as a class, if we've gotten a C or below on them as a class, we're going to go over these, and as well as the full open-ended. So if there are any other additional questions that you would like to go over from the multiple choice, please let me know. And we can do that our next class, or I can send out additional videos. So question 3, when a ball is thrown straight up with no air resistance, the acceleration is um, always going to be down because acceleration is determined by the force, which is going to be down, and it's going to be at that 9.8 meters per second squared, sorry. So acceleration due to gravity is always down. It doesn't matter whether we're going up, down, or at the very tippy top where our velocity is technically zero, we are still acceleration, or we're still accelerating downward. Next we have question 10. This is a great question, hint, hint. So one thing with any graph, be sure to take note of what the axes are. So on a velocity time graph, the slopes represent acceleration. So in this question, it's not really any point of value of what the slope represents because we're looking for displacement. So, well, what about the area under the curve? The area under the curve on a velocity time graph is the displacement. So when we look at the car, we're going to have this area being what displacement, or how far the car moves. And then say for the truck, you're going to have this bigger area. So that shows that the truck is going to travel a greater distance. The main reason is that the truck is moving at a greater velocity that whole time, where the car is accelerating during that time period, traveling less distance. So as an answer, we're going to have C, the truck will have traveled further than the car. What they're trying to get you to kind of say, I guess, in this question is what's happening at this point T. At that point T, the truck and the car are moving at the same velocity at the same time, not at the same position or the same distance. Question 14. Let's see here. So 14 was actually a mistake. That was not supposed to be included in this test or quiz or whatever you want to call it, because it was related to vectors. So I've already taken that out of this test in Schoology, so your grade has changed potentially slightly. I didn't think it would be fair to kind of include that as far as extra credit or anything because of not going over it. And we're going to wait about 15 to 30 seconds while my Apple Pencil recharges so I can finish out the video. So the next question was 22. Car drives 6 kilometers at 50 kilometers per hour, and then another 6 at 90. So the distance is the same, but the velocities are different. So this actually was one of the misconceptual questions that we talked about. Just looking at those two velocities, people are going to want to say, well, 50 and 90, the average of those two velocities is going to be 70. So, oh yeah, equal to 70. But when we look at vectors and time and distances traveled, or not distances, but displacements rather, and velocities, we're going to be moving at that 50 kilometers per hour for a longer amount of time. So we're moving at 50 more than we are at 90. So since distance is the common factor there, time is going to be different. So our average of what we're actually doing is going to be closer to that 50 kilometers per hour. So it's going to be slightly less than that 70. So of course you're going to pick C, less than 70 kilometers per hour. This is a question that you're probably going to see a lot in maybe AP Classroom and on the actual exams and mocks and things like that. That's a question that I've seen year after year on the actual AP exam as a multiple choice question. Next one we have is 24. This displacement for the car from 0 to 8 seconds. This is a velocity time graph. So the little hint is that the area under the curve is going to be, or under that line, is going to be the displacement. So we can break this up into several different shapes, triangles and rectangles. So for 0 to 2 seconds, we have a triangle, so 1/2 base times height, so 1/2 of 20 times 2. So 20 times 2 is 40, half of that is a positive 20. And then 2 to 4 seconds is 2 seconds, so times 20, that's going to be 40. And then we can see this is the same shape, and it's area under that line, so we don't have to worry about that negative slope because it's base times height. Where we do have to be concerned with the negative is underneath of our x, or our time axis. So from 6 to 8 seconds, we have 2, that's 2 seconds, times our negative 20. So 2 times negative 20 is negative 40, half of that, or I'm sorry, 2, it's a little late at night, sorry. 2 times 20 negative is negative 40, half of that, negative 20. So in a sense, these two could cancel out, and we just look at our two positive ones. Or we can look at it as a positive. We moved overall in the positive direction 80, and then negative direction 20. So that's going to result in positive 20, or 60, sorry, rather. Our next one we're looking at is same graph, but we're only looking for the first 3 seconds. So we kind of have to divide it like this, where we're looking in these areas. So we already knew some of the information from this, where this was 20, and this is only 1 second, because this is the 3rd second, so 1 times 20 is 20, so we only moved 40 seconds, or 40 meters rather. Question 27. This one was a little bit more involved. This was converted, I believe, from a open-ended one. So one thing to note, any multiple choice question, whether it's on a test, quiz, midterm, meaning our mock exam, our mock final, or the real AP exam, you want to kind of do some time management. If you're seeing that a multiple choice question, which is only worth 1 point, is taking a long time, it's almost better to skip that and come back in the end, because you have a 1 in 4 chance of getting it right, and spend time on questions that you can have a higher confidence level on to getting those multiple choice questions right, or an open-ended question which may take you more time. So this one, we're looking for this traveled into 28. The velocity at 5 seconds. So 27 is going to be a little bit easier. 28 is going to be more lengthy. So we want to know at 5 seconds how fast we're going. So looking at this graph, if we have an acceleration at this point of 0.4, that means we're speeding up. So we're going to speed up until 2.5 seconds and then remain at that velocity for the rest of our time to 5 seconds. So whatever we're going at 2.5 seconds, velocity-wise, we're going to be going at 5. So since we know some other information, so our initial velocity was 1, our acceleration was 0.4 meters per second squared. We're moving for 5 seconds, but we're only accelerating for 2.5. So technically the time that we're focused on is at 2.5, because the velocity at 2.5 and 5 is the same, because there's no acceleration, meaning no change in velocity. So we can use this equation. Forgot units. And calculator just to confirm that. So we're going to be going 2 meters per second. So that leads us into 28. And now I think these question numbers are offset a little bit because I deleted that one vectors question. So just be aware of that. So then this is now how far did we move? Same graph, same scenario, still traveling at that initial 1 meters per second. So right here, we kind of know that our velocity is 2 meters per second at that 2.5. So what we need to do, we can't do any necessary tricks of area under the curve per se. You could have done that here with knowing that we were moving at 1, and then whatever area that was, it happens to be 1. So if we start at 1 meters per second and our change in velocity was 1, then we were definitely going 2. So let's break this into parts. There's going to be 3 parts because we're moving in all 3 sections. So we're going to cover a distance in all 3 sections. So the first part, initial velocity of 1, acceleration of 0.4, time of 2.5, which we have enough information to do some calculating of displacement for that first 2.5 seconds. Just putting that as a subscript. So my displacement this was 0.4. Plug that into a calculator, and I get, right, just double check my math. .75 meters. So that's just the first of 3 different portions. During this middle segment, we're moving at a constant velocity. We know that because our acceleration is 0. So the equation that we're going to use is simply the first part of this equation, kind of, where our VI is our constant. So this is going to be, say, 2.5 to 7.5, where we were moving, we figured that out in the previous question, for 5 seconds. So we traveled 10 meters. So in the end, we're going to have to do some adding of answers here. And the last segment, we are slowing down because our acceleration is in the opposite direction. So we're going to still use that same equation that we used in the beginning. Where at the end of this middle part here, we were still going 2. So that's our new kind of VI towards the last segment. And that last segment of the graph is going to be for 2.5 seconds because it's 7.5 to 10. That acceleration is negative 0.4. And then that same time. Finally, plugging that into a calculator, we get a negative 7.5 meters. Or, I'm sorry. Just want to double check that. I can't read my handwriting. Just bear with me 1 second. Just want to make sure everything in Schoology is correct. Okay, yeah, that's what I thought. Sorry. Didn't have my right negative there. That's going to be 3.75. So when we add all 3 of those displacements together, we're going to get our answer of 17.5. 29. We had a couple of similar problems, I think, in the homework with this, with like a reaction time. So this was in kind of visualizing the scenario. For the first part of that motion at half a second, we're going to be moving at a constant velocity at 25. So if we're moving at a constant velocity, this equation comes into play. So for the first half a second, actually we can do it all in one shot, really. Oh, okay. So during that reaction time delay, our car has moved 12.5 meters, which is kind of scary of how far we actually move when we're driving with a half a second reaction time. The next portion is coming from how far we're going to travel when we're slowing down. So we know our initial velocity, we know our acceleration that we're going to slow down at, it's going to be negative. We don't have the time though, and we're looking for the distance. So the equation that does not have time in it is the one that we need to use. Smaller. So we're coming to a stop, so our VF is 0. Our VI was our 25. Even though we're going to be doing 25 meters per second for that reaction time, that's still going to be our kind of initial velocity when we start to slow down. Since we are slowing down, our acceleration is negative, and we can solve for delta x, where delta x is going to be 31.25 meters. So we're the first delta x here is when we were moving at a constant velocity, and then the 31 when we were slowing down. Add those together to get our total distance that we traveled. Okay, so those are the multiple choice. If there are any other questions for that, please let me know through Schoology or during next class, and we can discuss the test further then. So I want to go over the open-ended now. So in the open-ended, again, this is kinematics. It's not very difficult conceptually. It's very meticulous, meaning we have to visualize the problem and almost have like a plan, step by step, modeled out in advance. So definitely sketch a diagram, what information we know. So we know we have this rocket. Just going to kind of use arrows. My artistic abilities are not very good. And as it's going up, its acceleration is going to be 20. Our initial velocity at the beginning was 0. The time it takes us to get to the point where we're still accelerating because we still have fuel. At some point afterwards, we're going to run out of fuel and not accelerate at that 20. So for the first stage of our rocket, this is pretty much what we looked at in the homework. It took us 4 seconds to do that, and we traveled 160 meters. Wait, no, we have to calculate that. Sorry, can't advance. So that's what we know. And then we continue to go up in our rocket because if you envision it as throwing a ball up in the air, when the ball is in your hand while you're moving your hand upward, it's accelerating at some rate. When it comes out of your hand, it's still going to move upwards, but as soon as it leaves your hand, it's going to start slowing down because gravity is pulling against it. So that second stage, the acceleration changes to downward. So that's where these two stages are, these two parts of the problem where acceleration are changing. So the first thing we could do, we have all of the information for that first part. We can kind of like isolate this section here and find out how far we moved. So part A is going to be what's the total change in the vertical, the delta y. So what about the first stage? Well, the equation that we can use, since we don't have that final velocity, it can't have final velocity in it, unless we go find that out first, is delta y. And yes, I'm putting delta y because we're talking the y direction, not x direction. This whole first term drops off because our initial velocity was at rest. And the time we were given is 160 meters. But that's for just this first portion. We still need to find out that second stage when the rocket shut off, but we're still going upward. So the trouble lies is that we only have acceleration, meaning we know it's under the influence of gravity, but we kind of can cheat and know at the very tippy top its final velocity is 0. So from the other information that we know, can we find out right when it reaches this point, how fast is it going? So within this like orange box, what is the final velocity? So we can figure that out. Again, right now it should be pretty easy to eliminate equations because we only have 3. So at the tippy top of that accelerated stage where it's moving at 20 meters per second squared acceleration, we can figure out how fast it's going. So it's going to go at 80 meters per second. And I did, I think in speaking with some people or looking at solutions, some people reason that out, that if you're starting at 0 and our acceleration is 20 meters per second for every second, and you move for 4 seconds, every second you're increasing by 20. So it's going to be 20, 40, 60, 80. So right here, you're going to be going at 80 meters per second. So this actually becomes our new initial velocity for the second stage. So this box is now our second stage where our acceleration had changed. And yes, we're still on part A. I know, it takes some time, it takes some organization, and what we're going to find out is the key is in the method of drawing our diagram, identifying variables. What equation can we use? So we're going to redefine initial velocity is now 80 because it's the next segment of our travel. And we don't have time, we have acceleration, we have our final velocity. So since we don't have time, we can't use an equation that has that. So we can plug in everything that we know. Making sure we put negative 9.8 meters per second squared because we're slowing down, because the force is down and we're going up. And we plug that in. And I'm just going to put the subscript 2 to show that that's my second stage. And this might be my first stage there. And it's going to be 326.5 meters. But again, we're not done because we have our 2 stages, our accelerated at 20 and then our accelerated at negative 9.8. So our total travel has to be 326 plus that 160 So a lot, I know. So just that segment was worth 3 points of the 7. So where you could have lost points, if you didn't indicate what equation you used, choose different color here, what physics equation you used, you probably lost a point. And I know it's annoying. If you list them all in the beginning, there's only 3 right now. Um, that's those are easy points on the AP exam. If you indicate which physics concept or equation you're using, that's showing some level of understanding. So make sure you're doing that to get those simple points. Some other points lost. If you didn't show units, I'm a stickler for units, and then so is the College Board. So that's showing a level of understanding. Another point could have been, and again, this will change by person to person, the level of the detail, what you did. Simple mistakes I'm okay with. So let's say you got the, delta y here wrong, but you continued that same correct concept or same solution that is correct, minimal point loss. So you can have actually all the wrong answers and maybe get a 6 out of 7, depending upon how you showed your work and what went wrong. You definitely need to show me that there was a negative 9.8, and then of course there was the 2 stages. So that was all just A. That was 3 out of that 7 points. The next part was part B, and finding the time it took to get to the top. So this was a little bit easier, where we had that initial time of 4 seconds. We knew that. So now we have to find out how long is it going to take us to run out of speed, kind of. So we know our initial velocity is going to be the 80, and we're going to go to 0, and we know our acceleration is negative 9.8. So we can use this equation, where we're at the very tippy top, we're going to be at 0. Again, this is the second stage, so our velocity was 80. And we're under the influence of gravity. And solve for our time. And then we get 8.16 seconds. And again, this is the second stage. So if we add the 4 seconds from the first one, we get our about 12 seconds, or 12.16 seconds total for our time. And that was just good to get to the top. And then finally, I was flexible with part C. So let's go back to this one. So part B was worth 2 points. You need to show me an equation that you use, a physics equation. Oops, wrong highlight. Definitely show me some units and correct values and combining those 2 stages. Part C, we had a acceleration versus time graph. And you had to show important numbers or values that were located on the graph. So we had acceleration in time, seconds, meters per second squared. When we're solving something, make sure we're going with the flow. I've had some cases where people gave me on their paper, at the top of the page was part C. Then they had A, then they had B. Go with the correct flow. It is purposeful sometimes that, by the time you get to C, you're actually just putting graphically what you've already figured out. So we knew an important value was that in the beginning it's 20 meters per second. Oh, we don't really need to put that because it's already listed on there. So we're going to do that for 4 seconds. So we're going to go at 20 meters per second for 4 seconds. The rest of our travel is going to be at a negative 9.8, which would be, again, okay, so don't draw this. If I did this, is that a good qualitative or quantitatively drawn graph? No, because these two distances look about the same. Try to make them as close as you can, and don't just put numbers in there to make them look right. So if I'm going to put 9.8, it should be about, half that distance. Kind of didn't give myself room. Put something like this until about that 12-second mark. Feel free to put these in. So that's what you had to do to get the full 2 points for that part, showing me that it was a positive and then a negative acceleration and then those values and times. Some people went above and beyond and really answered the question the way that it was written. I've seen this before on AP or College Board questions where it's not very clear. It just says show a graph for the motion of the rocket. And we know the rocket's going to go up and then come back down, which is kind of a mean trick that they were expecting you to not just look at the upward stage, but figure out how long is it going to take to come back down. I didn't necessarily worry about that. If you did that, great. That means you're kind of looking at the big picture and the question wasn't specific. And some College Board questions or AP test questions are not specific. So you need to put everything that you know about that scenario into that graph or scenario. So hopefully this was clear enough. If you have more questions, send me a Schoology message, or we will have some open forum time the next time we meet in class.